Hello and welcome everybody to another episode of Books and Bytes. Today, we're taking a deep dive into Euclid's Elements.
Oh yeah, this one's a classic.
I know, right? It's one of those books that's been super influential for like over 2,000 years. It's basically the foundation of geometry as we know it.
For sure, and it's still taught today.
Exactly. And, even just looking at it, my copy here, the Project Gutenberg ebook of the first 6 books of the Elements of Euclid by John Casey. It can feel a little intimidating. Where do you even begin?
Well, it's kind of like, think of it as a journey of logical reasoning. Euclid starts with super simple definitions of like points and lines and shapes. And then he uses those to build up this whole system of like geometric truths.
Okay, so it's not just about like memorizing formulas. It's about understanding how those formulas came to be.
Exactly. It's like he lays out a method for proving these mathematical statements that we still use today. It's all about building these arguments step by logical step.
Okay, that makes a lot of sense. But, where does he even begin? What are those like foundational building blocks that he uses?
Well, right from the start, Euclid gets down to the nitty-gritty, defining the basic elements of geometry. Like, think about a point. We use that word all the time, but Euclid actually defines it as that which has no part.
Wow, okay, that's pretty abstract. Like trying to imagine something that exists but takes up no space.
It is abstract, but that's kind of the beauty of it. He's getting at that fundamental idea of a location, but without any size or dimension, and then he builds from there. A line, for instance, is defined as breadthless length.
So it's like a perfectly thin, straight path that extends forever, in both directions.
Exactly. And these might seem like simple ideas, but they really form the bedrock of like all of geometry.
Okay, so we've got points and lines.
Yeah.
What else does Euclid lay out in these early definitions?
Oh, all sorts of geometric figures. Angles, triangles, squares, circles. He even defines, different types of angles, like, right, obtuse, acute, based on their measurements.
It's fascinating how he creates this whole vocabulary for talking about shapes and their relationships.
It is. Like, he's creating a language for geometry. And once he has that language, then he can start building these arguments and proving these theorems.
Okay, so he's got these basic elements defined. What's kind of the next step in his system?
Well, after the definitions come what are called postulates. They're kind of like the rules of the game in Euclidean geometry. Assumptions that we accept as true without even needing proof.
Can you give us an example of a postulate?
Sure. One of the most famous is that a straight line segment can be drawn joining any 2 points. It seems obvious, right?
Yeah.
But Euclid lays it out as this fundamental assumption from which he's going to build more complex ideas.
So it's like saying, let's all agree on this basic rule and then see what we can create from it.
Exactly. And these postulates, along with a set of what are called common notions, which are kind of like more general logical principles, they form the foundation for everything that follows in the elements.
It's like a recipe for logical reasoning. You start with your ingredients, the definitions and postulates, and then you combine them carefully to create something new and delicious.
I like that analogy. And the delicious results in Euclid's case are these theorems that he proves throughout all 13 books of the Elements.
13 books. Wow. Okay, we've got our work cut out for us. But I'm curious, what are some of those famous theorems he proves?
Well, one that you've probably heard of is the Pythagorean theorem. It states that in a right triangle, the square of the hypotenuse is equal to the sum of the squares of the other 2 sides.
Ah, yes. A squared plus B squared equals C squared. I remember that one from school. But did Euclid actually come up with that?
Well, the relationship between the sides of a right triangle was probably known even before Euclid. But what he did was provide a rigorous proof of it in the Elements. And his proof is actually a beautiful example of how he uses logic and previously established theorems to demonstrate the truth of a new statement.
So he's not just like stating facts, he's showing us why those facts are true.
Precisely. And that's what makes the Elements so powerful. It's not just a collection of geometric formulas. It's a system for understanding how those formulas are derived and how they connect to each other.
I'm starting to see how this work has influenced not just math, but the way we think about logic and reasoning in general.
Absolutely. Euclid's method of starting with these clear definitions, laying out these basic assumptions, and then building up to complex proofs has had a profound impact on Western thought.
This is already blowing my mind. But I know there's so much more to explore in Euclid's Elements. So what should we tackle next?
Let's dive into some of the specific constructions that Euclid outlines in the early books. He shows us how to create all these various geometric figures using just a straight edge and compass, and the methods he uses are incredibly clever.
Okay, ready to put on my geometry hat and get to work. Lead the way. Okay, so you mentioned constructions. What kind of things can Euclid actually, like, create? With just a straight edge and compass?
Oh, you'd be surprised like how much he can do. For example, in proposition I.10, Euclid shows us how to bisect a line segment, meaning to like divide it perfectly in half.
Okay, I vaguely remember doing that in school, but we definitely used rulers.
Yeah.
How do you even begin to find the midpoint of a line with just a straight edge and compass?
Well, imagine you have a line segment AB.
Okay.
So Euclid's method involves like drawing a circle with A as the center and a radius longer than half the length of AB. Then you draw in another circle with B as the center and like the same radius.
Okay, so we've got these two overlapping circles. How does that help us find the midpoint?
Right, so the circles, they intersect at 2 points. Let's call them C and D. Now, if you draw a straight line through point C and D, that line will bisect the original line segment AB.
Wait, really? That seems almost too simple, but I guess that's the elegance of Euclid's approach.
Exactly. And the proof that this construction actually works relies on the properties of circles and triangles that Euclid has already established in earlier propositions. It's all about building up knowledge step by logical step.
It's like a puzzle where each piece fits perfectly into the next.
That's a great way to put it. And these constructions aren't just theoretical exercises. They have practical applications too. Think about like architects and engineers who need to create these precise designs. Euclid's methods give them the tools to do that with very minimal equipment.
So even thousands of years ago, Euclid was providing solutions for, like, real-world problems. That's incredible.
Yeah, it is. And the elements are full of these ingenious constructions. He shows us how to construct equilateral triangles, perpendicular line squares, even regular pentagons, all with just a straight edge and compass.
It makes you wonder, how did he even figure all of this out?
Well, we don't know a ton about Euclid the parson himself, but his work definitely suggests like a brilliant mind that was obsessed with order and logic. He wasn't just satisfied with like knowing that something worked. He wanted to understand why it worked and be able to prove it.
It's that dedication to rigorous proof that really makes the element such a landmark achievement.
Absolutely. And that approach to thinking has really resonated throughout the centuries, influencing fields far beyond just mathematics.
Like what?
Well, think about scientists and philosophers and even lawyers. They've all adopted Euclid's methods of reasoning to build their own arguments and like systems of knowledge.
Hmm.
Think about the scientific method. It's all about forming hypotheses, testing them with experiments, and drawing conclusions based on evidence.
It's like a direct descendant of Euclid's approach to geometry.
It is, and even in areas like law. You see echoes of Euclid's influence in the way arguments are constructed and evidence is presented.
So even though most people might not study Euclid's elements directly, his ideas still kind of permeate our culture and shape the way we think and reason.
Absolutely, and that's why it's so valuable to kind of revisit this ancient text. It reminds us of the power of logic and the beauty of a well-constructed argument.
This deep dive is already, like, reshaping my view of geometry and its place in the world. But I know there's more to explore, so where should we head next in our Euclidean adventure?
Well, we've explored constructions and proofs. How about we take a closer look at some of the specific theorems that Euclid proves and see how they kind of reveal this hidden beauty and order of geometric figures?
Sounds good. I'm all for uncovering some geometric gems. Lead the way. All right, so we're back and ready to uncover some more of those geometric gems.
Yeah, and it's amazing. We're still finding insights in this text from so long ago.
It really is like we're on an archaeological dig or something, but instead of, artifacts, we're discovering mathematical truths.
I like that. And today I thought we could dig into some particularly beautiful stuff in Book 3. It focuses on circles.
Those circles, they're everywhere, like nature design. I'm curious what Euclid has to say about them.
Well, one theorem that really stands out is proposition 3.20. It deals with inscribed angles in a circle. So, imagine you have a circle and an angle whose vertex is on the circle's circumference.
Okay, I'm picturing it. The two sides of the angle are chords of the circle, right?
Exactly. And that angle intercepts an arc of the circle. Euclid's theorem states that the measure of that inscribed angle is equal to half the measure of the central angle that subtends the same arc.
Hold on, central angle. Remind me what that is again.
Oh, sure. A central angle is an angle whose vertex is at the center of the circle. So like if you drew a line from each endpoint of the arc to the center of the circle, that's your central angle.
Okay.
And the inscribed angle with its vertex on the circumference will always be half the size of that central angle.
That's so cool. It's like there's this hidden relationship between angles and arcs within a circle.
There is. And this theorem actually has some interesting applications. For example, if you know the measure of an inscribed angle, You can use it to calculate the measure of the central angle and therefore the arc it intersects.
Oh, so it's like a geometric puzzle piece. Helps you solve for the missing information.
Exactly. And this theorem is just one of many that Euclid uses to unlock the secrets of circles. He explores like properties of tangents, chords diameters, building this whole system of knowledge about these really fascinating geometric figures.
Yeah, it's incredible how he weaves together, logic and shapes and relationships to create this intricate tapestry of like geometric understanding.
It really is. And, as we move towards like the later books of the elements, we see Euclid tackling even more complex concepts, like the geometry of three-dimensional objects.
That's right. He doesn't just stick to those flat shapes. He ventures into the world of solids, exploring cubes, pyramids, even spheres.
Exactly. And while those concepts may seem more advanced, they're all built on the same foundation of definitions, postulates, and logical reasoning that Euclid established way back in those early books.
It really is a testament to the power of his method. He
Yeah.
starts with these simple building blocks and then constructs this whole universe of geometric knowledge.
I couldn't have said it better myself. And what's truly remarkable is how Euclid's work has transcended the boundaries of mathematics.
You mentioned earlier how his approach to reasoning has influenced fields like science, philosophy, law.
Yeah, it's all about clear definitions, logical deductions, rigorous proof. That's become a model for building knowledge in so many different disciplines. Think about the scientific method. It's forming hypotheses, testing them with experiments, drawing conclusions based on the evidence.
Yeah, like a direct descendant of Euclid's approach to geometry.
It is. And even in areas like law, you see echoes of Euclid's influence in the way arguments are constructed and evidence is presented.
So even though most people might not ever study Euclid's elements directly, his ideas are still all around us,
Yeah.
shaping the way we think and reason.
Absolutely. And that's why it's so valuable to revisit this text. It reminds us of the power of logic and the beauty of a well-constructed argument.
This deep dive has been incredible. We've gone from basic definitions to complex theorems constructions to the theory of proportion. We've even gotten a glimpse into that world of solid geometry.
Yeah, it's been quite an adventure, and even though we've only scratched the surface of the elements, hopefully our listeners have a new appreciation for this timeless work.
I know I do. And made me realize that geometry isn't just about shapes and formulas. It's really a way of thinking, a way of understanding the world around us. And Euclid's Elements is like the ultimate guidebook for that journey.
Well said. So I guess as we wrap up this deep dive, I'd like to leave our listeners with one final thought. How can you apply the principles of logical reasoning that we've explored today to your own life, to your own decisions and beliefs?
That's a great question to ponder. It challenges us to think critically, to question our assumptions, and to try and build our own arguments with clarity and rigor.
Exactly. And who knows, maybe in doing so, you'll uncover some hidden truths and beautiful connections that you never even knew existed.
Thanks for joining us on this deep dive into Euclid's Elements. We hope you've enjoyed the journey, and we encourage you to keep exploring the world with curiosity and a logical mind. Until next time.